So my name is JJ Kavelaars. I have a PhD in astronomy, and I work as what's called a principal research officer with the National Research Council of Canada. So the principal research officer is just basically a tenured researcher within the National Research Council's system. And I work out of an office in Victoria, British Columbia, where I'm connecting to you from right now. There's an NRC in the United States, which is quite a different kind of NRC than the one here in Canada. The National Research Council is comprised of kind of an array or matrix or whatever of different research centers, each specializing in some different aspect of physical sciences research, ranging from people who do building structure research to measurement and standards to nanoparticle interactions with matter to high energy physics to astronomy. So I'm at the Astronomy Research Center, which is named after Gerhard Hertzberg. It's called the Hertzberg Astronomy and Astrophysics Research Center. And Gerhard Hertzberg was an NRC researcher who won the Nobel Prize back in the 1980s for his discovery of molecular lines in the interstellar medium. But he was really a very strong chemist and did a lot of fantastic research trying to understand the chemistry of the interstellar medium and also to do chemistry of compounds here on the Earth. So,
sure. Do you mind if we jump straight into some student questions? Because I got some emailed to me, and guys, as always, if you have any questions, pop them in the chat, and we'll let you ask Dr. Kavelaars yourself. So one of the kids wanted to know, what was it like? Can you talk about the process of when you were part of the team that discovered several moons? You discovered several moons around Jupiter, Uranus, Saturn, Neptune. Like, I'd imagine just discovering one moon is a big deal, but you discovered a whole bunch of moons. So what is that?
Sure. So that actually was a pretty transformative episode, in fact, in my early research career. So I was a graduate student at the time, working in a completely different field. I was trying to understand the nature of dark matter and how galaxies hosted dark matter. So dark matter is this matter that pervades the universe and causes all kinds of effects that we don't quite understand. What happened was I had a friend, I became friends with a guy basically in the desk next to mine who was studying the solar system. And he was doing all this work on trying to understand how bodies in the solar system moved. And we got to talking about different things we could do. And then he went off to Cornell University, which had access to a 5-meter telescope in California called the Hale 200-inch. And the 200-inch telescope had never been used to look around the solar system for small bodies. So we decided we would look for small bodies around the solar system. And because we were graduate students, we basically accepted any time they would give us on the Hale. And we got time on the Hale. We flew down to California to use it. But on the flight down, we realized that they've given us basically a completely useless night for looking for things in the very distant solar system. It just wasn't going to work. But we just sort of like brainstorming on the plane and came up with the idea that, well, what if we looked around Uranus to see if there were any unknown moons of that planet? And it's like we had nothing else we could do. Basically, it was like we can do that or we can just sit on our hands all night. So let's just do that. We don't think it'll work, but because certainly this has already been done by others. So we did that, and really right there on the first night, taking the observations, what you do is you take an image of the sky, and then you wait an hour and you take another image of the sky, and you look for anything that's changed position in those two images. And you do 3 to make sure that you're really seeing something. And look, like just amazingly, we got the second image and we're just looking between the two of them and we could see, wait a minute, there's a little point of light moving from one to the other. Okay, don't get too excited. That could just be an asteroid that happens to be in that part of the sky. Then the third image came down and it was exactly the right kind of motion. One image to the next, and you say, hey, that's actually something moving at the same motion as Uranus. And so it became two possibilities. This could be a new moon of Uranus that no one had ever seen before, or this could be an asteroid which was just mimicking that behavior. So we took another set of images, and there was really nothing else we could do that night. Essentially, you can't tell the difference between these two kinds of possibilities just in one night. So we had all our data, we took it all back with us to our institutions and we searched through it. We found a couple more things that looked like they might be moons of Uranus. It was all very, very exciting. We would actually call each other on the phone. This was like back in that time when making a long distance phone call actually counted for something. So as graduate students, we were racking up the long distance call charges on our supervisors' accounts. But we were so excited about what we possibly had. Anyway, the Cornell gave another night to this project because we told them about this Uranus thing. And we went down and took a couple observations, and within basically minutes of having arrived or the sun having set, we knew we had discovered satellites of Uranus. And I've never done this in a telescope prior, which was we hooted and hollered and high-fived each other that we had actually managed to do something which was just really unimaginable to us at the start. Like we just really couldn't believe that this was something that would be possible. It was, you see athletes who win a big game, right? And they're super charged about it. This is scientists who won a big game that they really just can't imagine having achieved such a thing. So, and that actually opened up a whole new field of research. Like people, once we published these discoveries, it came like a little gold rush. People realizing, oh, there were whole suites of undiscovered moons around the planets. And other groups started to do it and look for them. And that was really affirming of the kind of our feeling of jubilation having made that discovery.
That seems like it would be like out of a movie. Like when you make that big discovery, like how often, if you can kind of give us insight, how often does that happen where new things like major objects like moons are discovered in our solar system?
So the satellites of the giant planets, so what happens is, right, is the discovery was basically incredibly novel because of the duration of time between the previous time someone had done this and when we had done it. We demonstrated a new capacity for facilities like this telescope. And so then many people started doing it and they would all be finding these moons of these planets. And then that went on for about 5 years and then it's tapered off to nothing because it's basically that scientific area has been mined out. So now what happens is we try different things. We try different kinds of searches. So right now I'm engaged in a search where we're trying to find the most distant objects in the solar system. And it's the same kind of experience where you discover, oh, I've just found something that's farther away than any of the previous things that are known. And you're kind of pushing the boundaries of our knowledge of the solar system. And so you get that. It's not quite as dramatic, though, I would say, as the satellites of Uranus discovery, largely because we kind of expect we're going to find distant things in the outer solar system. We know they're out there. We're just digging into the dirt to try to find them. With the satellites of Uranus, it was just because we were grad students and didn't know any better that we went off and did it. And that's actually an incredible part of scientific discovery, right, is naivete. So just not knowing you shouldn't ask this question often leads to a discovery that is novel. And that's where we're constantly trying to bring, new thinking into a field. And a lot of times older researchers, what we do is we basically just change fields because our thinking in the field we're in has kind of, we're not in a rut, but we're following a well-known track, right? We've walked this path many times. I know how to get from A to B. Every now and then you have to be brave and say, you know what, I'm going to take a different path because I will ask questions that really an experienced researcher would know not to bother asking, and then new things will come up out of that.
Yeah, that's all like really exciting stuff. So we got 10 more minutes of questions, then we'll let you go. So one of the kids wanted to know, how have you seen technology influence your industry?
Yeah, so hugely. When I was a wee undergraduate, which is in the 1980s, I went to a lecture by a Nobel Prize laureate who won the Nobel Prize for their invention of something called the charge-coupled device, which is a device which is kind of like the device that's in everybody's smartphones these days, which are CMOS devices, but it's the basic same concept, where photons hit some silicon and cause electrons to escape from that silicon, and the electrons are captured in the device, and you can record an image in this kind of process. At the time, it was Nobel Prize winning stuff that this CCD thing had been discovered. The first data I worked on as a graduate student was from one of the very first charge coupled devices used to take images in astronomy. We barely had the computing capacity to do anything with these things, okay? Then as I went through my career, these devices got more and more refined and better. The search of the satellites of Uranus was possible because the devices had gone from being maybe 10 by 10 pixels to 100 by 100 pixels up to thousands by thousands of pixels. And in fact, now they're at the point where we make these arrays of these things, which are hundreds and hundreds of individual cameras all mosaic together, and each camera is something like 4,000 by 4,000 pixels. So imagine, you've got your cell phone camera, but you take 300 of them and smudge them together to make a giant imager. And so the sensitivity of the cameras that we use in astronomy or in research, we detect about 80% to 90%, even 95% of the photons that hit the silicon. Okay, whereas your CMOS device in your phone is probably managing a few percent of the light, because you're taking pictures in well-lit situations, where in astronomy we're doing it in very dark conditions. So that technology has completely transformed how astronomy is done. Astronomy is not done like it used to be done. It's done completely differently. It's highly precise, very computer-driven, and that computer-driven has moved us now towards using AI and machine learning. And basically, we take our imaging, these giant mosaic images that we get from the telescope, and we shove them into machine learning AI-driven algorithms that we develop, and those things do the grungy data analysis work. I'm just writing a paper with a colleague right now on our latest machine learning adventures with this AI technology on these CCD cameras.
And there's a lot of exciting stuff that you've been involved in throughout the years. One of our kids, they wanted to know, what was it like discovering distant planets, and what is your theory on life possibly existing on distant planets? And he's not saying intelligent life, just life in general.
Sure. Yeah. So the scientific consensus is that life arose on Earth through essentially processes that are very common in the planet formation, and that life arose very early post-planet becoming solid. And there's nothing very special about those processes, other than we think there has to be basically organic liquids available for this to work. So you need to be in the right kind of temperature zone, and this is often called the Goldilocks zone around a star. So we started finding planets for the last 20 years. We've been finding planets in the galaxy around us. And those planets are, some of them, after 20 years, we found actually a number of them that we could say are in the right zone of the solar system to be, they're planets in the right zone to have this liquid organics. So I think the chances there's life on them is actually basically 100%. That there would be no other life in the galaxy, even in the local neighborhood of our galaxy, would be really weird, just completely against basically the scientific hypothesis of how things should work. The same way the Earth goes around the sun like all the other planets, rather than having the Earth at the center, which is this kind of transformation of Galilean thought, and Copernicus, we have the same idea that really we should consider that the system that we have here is very common. And if it is very common, then there should be life in lots of planets around lots of stars. Yeah.
That is, that's mind blowing. And so you guys heard it here first. So there you go, leading scientist on it. So before we let
you go, dedicated to looking for planets with life on them. And we pour a lot of money into that. And it's not because we think it's a complete, goose chase. We actually think this is a very doable thing, probably within the next 15 years.
Now, would that be with the studies that you guys did with 486958 Arrokoth, like sending something out to, he discovered, again, we're discovering planets and moons. He also discovered something so far away. And can you describe it a little bit real quick before we let you?
So we have I'm part of a space mission called New Horizons, which is run by NASA. And NASA is a great organization that allows international scientists to join their projects. So I belong to the New Horizons science team. And that spacecraft basically is just on a trajectory going straight out from the sun. And when it was launched, it was going to go to Pluto and explore Pluto, which we've done. And we told NASA afterwards, we'll find something else to look at. Honestly, we will. And we actually did. We found a really small, about 30 kilometers across object in the very distant solar system. It's about 40 times farther away from the sun than the Earth. And that very distant object, we flew up really close to it. And it has an unusual structure to it. And it tells us a lot about the original processes by which planets form and how planetesimals, the building blocks of planets, how they come together. So that spacecraft is continuing on its journey, and we're continuing to look for more things for it to explore.
And it took about 2.5 Earth years, right, to get to there. Is that what it was about?
Yeah, well, it took 2.5 Earth years to get from Pluto to the next thing. Yeah, and it took about 7 years to get from Earth to Pluto. So yeah, that
is nuts.
There are people long retired on this project.
Yeah, we had a guy who was a guest, side story, guy who was a guest, and he was on he was part of the NASA team that shot the rocket up in the 70s that went by Saturn. And by the time it got to the outer planets, he had been retired for 30 years. He has since passed away now. He's since passed away. He didn't even get to see it get there. Okay, so before we let you go, this is the final question. Is there any advice that you could give to these kids as they go off into the world and figure out what they want to do?
So the big lesson that I learned is about how you behave when you become curious about something. And that is chase that curiosity. You become, how does X happen? How does X work? Is X possible? Whatever you become curious about, pursue that, because that curiosity will drive you and that will motivate you into places that others won't go, and you may end up coming across something that's quite unique and quite interesting for the rest of the people around you to know about. And then they become curious about that same thing. And, when you're young, you can spend some time chasing down things you're curious about that maybe turn out to not be that useful. And, this whole idea that, you've got your youth, use it in some way that is interesting. And to me, the most interesting thing is to say, well, what do you think is interesting? Because you don't know better than to not think that something's interesting. And pursue it, look into it, find out how, follow that curiosity and transform the way we all live. Everybody counts on the next younger generation to do that kind of thing. And that's what's critical.
Well, thank you so much for your time. We can't thank you enough. This was, I am totally into the astronomy and all that kind of stuff. And thank you for all you've done for science and exploration in our solar system and out of our solar system. Guys, we have some amazing guests coming up tomorrow and next week and the week after. Feel free to check them out and sign up for any and all. I put the link in the website, edutainmentlearning.com. And JJ, before we let you go, before I end the meeting for all, I'm going to allow all to unmute. And can we all say thank you to Dr. Kavelaars for taking the time out of his valuable day to come talk to you guys about being an astronomer. Thank you so much, JJ.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.